live. Okay, so this is a video for my 40S Essential class, and we're going to look at word problems. And you're probably thinking, oh, we've already seen a couple of word problems in the worksheets, but what makes these ones different is, notice that this says sine and cosine law. So we don't know that it's on the sine law worksheet. We don't know that it's on the cosine law worksheet. It's our job to figure out which one of the laws we got to use. And on a couple of the problems later, it won't give us the diagram. It'll be our job to make it. So that's kind of the next level. Actually, it's the last level for this stuff. If you can do the stuff we're going to do in the next couple of examples here, we're not going to be able to stump you. You've got this stuff, right? Because that's all that we haven't forced you to do yourself yet, is to either make your own diagram or decide for yourself if this is sine law or cosine law. So let's get started on that. Example 1, boats are anchored at positions J, K, and M on a lake. Boats J and K are 80 meters apart. So let me make that full screen, and let's get a pen ready. So notice it doesn't say which one's which, so I guess that's up to us. I'll call this one J, I'll call this one K, and I'll call this one L. J, K, and L. Oh, sorry, it's not L, sorry. Guess I should read the question more carefully. That's better. J, K, and M. All right, so now that I have decided which boat is which, I should know the labels for the sides, right? So if this is angle J here, then the side on the right has to be little j. And if this is angle K up top, then side K has got to be at the bottom. And if this is angle M on the right, it's got to be side M on the left. Okay, so that's the first thing, is I have to label it. Now let's put our information on it. Boats J and K are 80 meters apart. So that makes M 80 meters. Can you add that to your diagram? J and M are 110 meters apart. So that's actually what K would be equal to. Can you add that to your diagram, please? And angle K, which we decided is the one at the top, is 120 degrees. Now, I could have chosen which, I didn't have to put J, K, and L in those spots, but I decided to because I did notice that, oh, K is actually a bigger than 90-degree angle, and only one of the angles in my picture looked bigger than 90 degrees. Would it have mattered much if I hadn't noticed that? Not really. As long as I keep the algebra and the formula right, it would have worked. All right, so what am I supposed to find? How far is it from K to M? So I'm actually looking for side J. So now, this is, I think, the hardest part of the question. Is it sine law or is it cosine law? When do you use sine law? You use sine law when you know an angle across from a side. And I do. I know that angle, and I know that side. So that's what tells me it's sine law. So I'm going to use sine law. So I'm obviously going to use okay, I'm looking for a side, so I put the side on top. So I'm gonna have to have side J over the sine of angle J. And the two that I know have to be the other part of the ratio. And I know side K, and I know angle K. So now I fill in the three things that I know. And, oh, hold on a minute. Hold on. Boats J, K, can we stop making that noise? Thanks. Boats J, K, and M are on a lake. J and K are 80 meters apart. J and M are 110 meters apart. Angle K is 120. Ah, problem. I actually don't know either of these two things. So I can't use that yet. But here's what I can do. I can actually find this. I can find, or wait a minute, sorry, I highlighted the wrong things. Let me start that over. I don't know either of these things. So J is the one I'm looking for, but I kind of need to know that before I can do it. So, does that mean I have to abandon sine law? No, because I can't use cosine law either. Cosine law I use when I know an angle between two sides. They only give me an angle that isn't between two sides. So no, I'm still with sine law, but I'm going to have to do this in two steps. I'm going to have to actually, first of all, find angle M. So the sine of angle M over M is equal to, and this is, again, this is the part where I know the two, so I have to use K and angle K. So my strategy is I'm going to find angle M first, then I'm going to use my 180 trick to find angle J, then I'm going to go back to this formula and find side J. So this one has to be done in two steps. 3 if you count the 180 trick as a step. So here we go. So let's plug in our numbers. I don't know angle M yet, but I know side M is 80. I know angle K is 120, and I know side K is 110. So let's find that. So the sine of M is equal to, cross and multiply, 80 times the sine of 120 over 110. So the sine of angle M is, and now I got to punch buttons. So I'm going to use this calculator. Step 1, always make sure that you're in degrees. We're good, we're in degrees. 80 times 120 sine divided by 110. So that's going to give me 0.6298 blah blah blah. So I have to do the inverse sine of that. I'll put an angle sign on that to remind myself that this is an angle, and my answer when I'm done will be in degrees. And there we go. Now, does it tell me where to round? No. Well, actually, this isn't my final answer yet anyway. I don't really want to round anywhere. So I'll just keep that number as 39.038, blah, 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 and that's in degrees. Now, remember, that's not my answer yet. I wasn't looking for angle M. I'm looking for side J. But now that I know angle M, I'll do this over here. I'll use my 180 trick. So angle J plus angle K plus angle M has to equal 180. And I don't know angle J yet, but angle K they gave me, and I just found angle M. So if I now add those two things together, so I add 120 to the number that's on my screen, I get 159.038 blah blah blah. And then how do I get angle J by itself? I subtract the 159 from 180. And I get 20.96, and then again, blah, blah, blah. These decimals going forever. Now notice I'm not rounding this number off. I haven't turned off my calculator. I haven't hit erase. It's still on my screen. But now I know enough to use this formula, because now I've figured out that angle there. So now I can plug it into that formula. So J over the sine of the angle I just found, 20.96, is equal to, and we knew K was 110, and angle K is 120. So J is equal to 110 times the sine of 20.96 over the sine of 120. And now I punch buttons. So I can do the sine of 20.96 first, since it's already on my screen. So sine times 110 divided by 120 sine equals. I'm getting 45, and again, I've already forgotten. Does it tell me where to round? Nope. So what's my rule when it doesn't say where to round? 2 decimal places is good. And again, if there was a provincial exam, they'd expect that's the way you follow the rule too. So 45.44, what unit are we in? Meters. And that's my answer. So let's kind of go back and take a look at this thing kind of overall. See how this works? It would have been nice if I could have just used this formula right away that I circled, but I couldn't. I had to kind of do another step first, another 2 steps. Step 1, I had to find angle M. So this was kind of, here, let me label this. This here was step 1. Step 2, I had to find angle J using the 180 trick. And then step 3 was to get to my answer. And that's the easiest way I could have done this question, is I needed all 3 of those steps to get the answer. So that's a fairly tough one. That's about as tough as sine law gets. The only thing that could have maybe made this tougher was what if I hadn't given you the picture. Although notice I didn't really label I had to label the picture myself anyway. So again, that's about as hard as this stuff gets. If you can do that, we're not going to be able to stump you with a sine law problem. All right, let's try the next one. A tower is supported by 2 guy wires attached to the top of a tower. Did you know that towers often have wires that attach them to the ground to hold them up? They're called guy wires. Did you know that until they built the Burj Khalifa building in Dubai, that the tallest freestanding structure in the world was the CN Tower in Toronto? But that's not the tallest tower in the world, because notice I said freestanding, which means no guy wires. There are no big wires attached to the ground holding up the CN Tower. It's freestanding. But if we were to count towers that aren't freestanding, there is a much taller tower than the CN Tower, only a few hours drive, like 3 hours drive from here. It's just west of Fargo, North Dakota. And for a long time, it was the tallest thing anybody had ever built. It was a radio and television tower for broadcasting in the days before satellite. Of course, you had to just send signals from tower to tower. And it was taller than the CN Tower by like 100 meters. I think it's still standing. The Russians built one that was taller, but it only lasted for about a year, and then a tornado blew it down. So the North Dakota one was the tallest thing anybody had ever built. Then somebody says, well, wait a minute. There is, in the ocean, oil drilling stations that go down from the surface much further than that tower is tall. And they have towers for communication on top of them. So if you take from the top of the tower above the water to the very bottom of the drilling below the water, you have things that are actually like more than 1 kilometer long. So isn't that the tallest thing anybody's ever built? Do you only call it tall if it's above the surface of the water? It still has to stand up. So I don't know. I don't know how you'd call it the tallest thing. I think the Burj Khalifa is still the tallest building in the world. And I think it's taller than any tower, too. I think it is the tallest thing in the world. Unless you want to count oil drilling stations and things that are underwater. Anyway. Anybody been to Dubai? I've had some students who've been in that building. Because apparently you can take tours of it, and you can go up to almost the top, and they have like restaurants and what do you call it, sightseeing floors. Like the CN Tower has a restaurant in the circular part, and then just an observation deck in the smaller circular part. I've been up the CN Tower several times. It's fun. It's not cheap. It's like $40, but it's a fun day. If you're not afraid of heights. If you're afraid of heights, don't do it. Anybody done the CN Tower? No? How about Calgary? Calgary's got a nice tower, but it's not nearly as tall as the CN Tower. This is clearly, I don't know, looks like a hydro pole tower, telephone pole. All right, let's do the math on it. Enough talk of towers. I like tall buildings and tall towers. They're fun. So what's the height of the tower? Okay, well, once again, they gave me a picture, but they didn't tell me anything about the picture. So I gotta label stuff. The wires are fixed to the ground on opposite sides, and they're 27 meters apart on the ground. So I'm gonna just draw a little line here. If I could get my pen to work. Come on, pen. There we go. 27 meters from here to here. That is an M. There we go. One wire is 19.3 meters long. Let me make that a little bigger for you. And it meets the ground at an angle of 53. I'm going to assume that's this one. Do I know for sure it's that one? No, but it doesn't really matter. There we go. How did I know to put it? How did I know to put the 53 down here instead of up at the top? Because notice it says meets the ground at an angle of 53 degrees. You see the logic on why I had to put it at the ground? All right, what's the height of the tower? Now, we're going to make an assumption here looking at this problem. You know what that assumption is? Is that the person who put up this telephone pole knows how to do their job and put it into the ground at a right angle. So guess what I can use to solve for this height? Do I need sine law? Do I need cosine law? No, people are shaking their heads. I can use SOHCAHTOA. So let's just use SOHCAHTOA. So on the left triangle, here I'll highlight it. In this triangle here, that's a right triangle, where this is from 53 degrees, this is a hypotenuse. And what's the h from this angle here? Is it an opposite or an adjacent? It's an opposite. Very good. So I don't need sine or cosine law to do A. I can just use good old grade 10 or 11 SOHCAHTOA. The sine of some angle is the opposite over the hypotenuse. So let's plug in the numbers. The sine of 53 degrees is h for height over 19.3. And who remembers the little rule? T for top, T for times. This is a times problem. H is 19.3 times the sine of 53, which is, and now I got to punch buttons. Punch buttons with me so that you double check to make sure that I do it right. 15.41. Does it say where to round? Nope. 2 decimals. 41 meters. Any questions on how I did that? Yes, when I test you on this stuff, I might throw in a SOHCAHTOA problem just to see if you remember it. And again, it's your job to figure out which thing to use. Which tool from your toolbox do we use? All right, now, what's the length of the second wire? Aha! So I would like to know this distance here. Can I use SOHCAHTOA? I mean, it's a right triangle on this side too, isn't it? But the answer is no. You know why? Because I don't know anything else about it. I don't know how big this angle is down here. I don't know how big that angle is up there. You might think, well, but we know the right angle. That's nice, but it doesn't help us. There's not enough information. I know this height now. I know how tall the pole is. But without another angle, I'm kind of stuck. I can't use SOHCAHTOA. So I got to go back now to, is it sine law or is it cosine law? What do you think? Okay, so now ignore the purple part. I'm looking at the whole triangle now. Let me get there we go. So now I'm looking at this entire triangle. I'm looking at my pen. Come on, there we go. Okay, so in that triangle, what do I know? Do I know an angle across from a side? So the height means nothing anymore. You can ignore the height. Pretend the height isn't even there. Pretend the telephone pole is invisible. What do I know? I know a side, the angle, and the side. I know an angle between two sides. What rule do you use when you know the angle between two sides? Is this sine law or is this cosine law? This is going to be cosine law. So I guess I need some letters. Let's use A, B, and C. So we'll call this angle A down here, which means that's side A, which is the one I'm looking for. I'll call this angle B up here, which means the 27 is side B. And I'll call this angle C down here, which means that hypotenuse thing that was, well, it was a hypotenuse in the purple triangle, but now it's just side C in the big triangle. All right. So let me shrink this a bit so you can see the whole thing as I go. So I'm solving for A, so I have to use A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Now, I've used these formulas so much I've got them memorized. Do you have to memorize them? No. Right now you can use your notes. On the test, we'll give you a formula sheet. We'll also let you bring in a piece of paper with anything you want on it. You can bring in a study sheet if you like. Okay? So, let's plug in our numbers. Which one's side B, the 27? Which one's side C, the 19.3? Minus 2 times 27 times 19.3 times the cosine of 53 degrees. And this is the toughest button punch, right? This formula is harder to use than sine law. All right, punch buttons. Again, please punch with me to make sure that I don't goof it up. Okay, I got a number. I'll give you a sec to catch up to me. And let's see if we get the same number. Punch, follow along, punch buttons. The more practice you get punching buttons, the better. That's super frustrating too on a test too. When you set it up right, you did everything right, and you lose a mark because you punched the buttons wrong. So frustrating, right? You knew what you were doing, your fingers failed you. All right, the number I got, I see some people looking at me like they're done, is 474.278, blah, blah, blah. Is that what you got? Guys who punch buttons? Anybody? Is this what you got? Uh-oh. Oh, I see a nod. Yeah, okay. So then, how do we find A again? What's the last step? Uh-oh. So I get some people shaking their heads no. Okay, I'm going to repunch then. I'll use a different calculator too. I'll use a fancier one. 27 squared plus 19.3 squared minus 2 times 27 times 19.3 times the cosine of 53 equals, no, I stand by that number, 474.27838, blah, blah, blah. If you're not getting that number, you're punching something wrong. Once I'm done the lesson, I'll come over and I'll help you with your calculator. You're just doing a button punch wrong. Okay, but remember, that's not the answer yet. I don't want to know what a squared is. I want to know what a is. So what's the last step? How do you turn an a squared into an a? I got to do a square root. So I'm going to square root my answer. And I get 21.78. This is in meters, right? Yeah, meters of wire. So there's the second. There's part B. Part C, what angle does the second wire make with the ground? I would like to know this, which is angle C. Well, now that I know side A, I actually have my choice. I can use sine law or cosine law. Which one's less work? Which one's less button punching? Definitely sine law, right? So I'm going to use sine law. So I want to find angle C, so the sine of angle C over C is equal to, and which two do I know? I know A and side A, because I just figured out side A. So I'm going to put sine of angle A over A. Okay, let's put in the numbers. I don't know angle C yet, that's what I'm looking for, but I know side C. What was side C? 19.3. And I know angle A. Angle A is the one they gave me, 53 degrees. And side A is the one that I just calculated, this 21.78. Come on, pen. 0.78. And by the way, I'm not rounding that to 0.78. I still have this number as the answer on my calculator. So I don't round until I get to my final step. That preserves accuracy. Here in the essential course, we don't really care that much. If you had an answer that was off by 0.1 or 0.2, especially, or 0.01 or 0.02, I wouldn't take off half a mark. But in the applied courses, they do. Like in the courses where the technical stuff matters, right? Say that you're doing calculations because you're designing something. You could, if you designed a part that was off by 0.1 of a centimeter, well, that's a millimeter too big or a millimeter too small. That means that part might not do its job properly. Let's say you were designing a piston for an engine that was 0.1 millimeter too big for the hole that it's supposed to sit in. It won't fit, right? So some things in the world you have to measure with an accuracy to them. So your calculations got to reflect that. Anyway, cross and multiply. The sine of angle C is 19.3 times the sine of 53 divided by 21.78. And I don't have to hit 21.78. I can use my answer button. So 19.3 times the sine of 53. Those of you who your calculator opens a bracket when you hit sine, don't forget to close it right there. Divided by my answer equals and now I'm going to totally blow your mind. Those of you who took pre-cal are going to know exactly how I did this. Angle C is going to be very close to 45 degrees. Let's see if I'm right about that. I'm almost out of room here, so I'm going to just kind of move over. Hopefully you're writing smaller than me. So, oops, not what I wanted. So angle C is the inverse sine of 0.707 blah, blah, blah. And let's see if I'm right about that. I'm guesstimating that this is about 45 degrees. Inverse sine of my answer, 45.05. Does anybody know how I know that? How did I know looking at that decimal that I was going to get 45 degrees? Guys who took pre-cal should know this. Remember your unit circle, people? Oh, sorry. The unit circle was so traumatic that you blocked it out of your memory. Those of you who have studied the unit circle know that the sine of 45 is root 2 over 2, which is about 0.707. So I just recognize that decimal. So there we go. There's we've done a problem that had SOHCAHTOA. We've done a problem that had cosine law. We've done a problem that had sine law. Now it's your turn. I want you to give this problem a try. I'm going to actually pause the video and let people play with this problem for a minute. The first thing you got to do is you got to make a triangle, like make a diagram of a triangle. Put all the numbers in the right place, and then decide whether it's sine or cosine law. And this is where, I wish this wasn't this COVID stuff. I'd put you in teams, and you could work on this together in teams. But we'll just work on it individually for now. Okay, so I'm going to pause the video, and I'll come back in a minute. We're back. And okay, we're going to now make the picture for this problem. So people use two transits to cite. So transits are basically these things here. We had a more technical word for this than one of the other assignments, I forget, but it's something a survey crew would use. And here's basically what they're saying. They're saying that the transits are along the same base. So they're in a straight line with each other. So here's basically the picture. I'm going to just maybe draw it over here. So the picture is going to look like this. I guess maybe I should put it down here. So I have a pole here, and let's see, top of the pole that is on the line through the transits, and the distances to the top of the pole are, so 19.8 meters. Come on, pen. 0.8 meters at an angle of elevation. What does elevation mean? It means going up. And then the other guy is looking at it from over here. And this distance, I should actually draw this one not as big. This one's a shorter distance. So a little shorter this time. Now I do have to make an assumption here. I have to assume that the two transits are actually the same height off the ground. Otherwise, this wouldn't be a flat line along the bottom. Okay? But if I didn't assume that, I wouldn't be able to do the problem. So there we go. That's the picture. And I would like the distance between the two people. So the distances to the top of the pole are 19.8 at an elevation of 38 degrees and 14.4. So in other words, the pole is actually here. That's the pole. What do I want to find? I want to find the distance apart that the two people are standing that are taking these measurements. So let's put on some letters, shall we? I guess I'll go angle A, angle B, and angle C. And side A is over here. Side C is over here. So I'm actually looking for side B in my picture, according to my letters. And what would be the easiest way to do this? Well, I could actually, this is a very open problem. They gave me lots of information. They gave me more information than I needed, actually. So I could do this with either sine law or cosine law, whichever one you wanted. If I were to use, either way, I'm going to have to figure out angle B. So I'll do that first. So angle A plus angle B plus angle C always has to equal, any three angles of a triangle have to equal 180. So I have 38 for angle A. Angle B I don't know. Angle C is 57.8. And if I add 38 to 57.8, what do I get? 38 plus 57.8. Looks like I get 95. Come on, pen. 95.8 degrees. Oh, whoops, that's not right. Hang on. Oh, there we go. Okay, so 180. Okay, and then subtract from the other side. So 180 minus my answer. So angle B is 84.2 degrees. So we can put that on the diagram. I just figured out that this is 84.2 degrees. And now I can use sine law or cosine law. I think I'll use sine law because it's less button punching. So side B over the sine of angle B. And notice I know A and side A, I know C and side C. I could use whichever one I wanted. So I'll use A. So let's put in the numbers. B over the sine of, I just figured it out, 84.2 is equal to 14.4 over the sine of 38 and then cross and multiply. So that's 14.4 times the sine of 84.2 divided by the sine of 38. And there we have it. Side B is what we're looking for, 14.4 times the sine of 84.2, which was my last answer, so I could just use my answer button, divided by the sine of 38. And I get 23.27. Somebody could punch buttons and check to make sure I did that right. See if you get that number. 23.27 meters. Okay. All right, one more. Have you ever seen one of these diagrams before, guys? Everybody caught up to me? You good? Okay. One more example. Ever seen one of these before? That's a compass rose. So that is how, anybody here been in Cub Scouts or cadets or brownies, or you've done some sort of orienteering course where they ask you to figure out a distance on a map and then maybe walk through a park or walk through the bush and try to figure out where you are? Chances are you had to use a compass or a compass rose. So a hiker plans a trip in two sections. Her destination is 15 kilometers away on a bearing of 70 degrees, or let me say that better, north 70 degrees east from her starting position. The first leg of the trip is on a bearing of north 10 degrees east. So here's how you do this. if you are trying to find this direction, north 70 degrees east, watch this. You say, okay, if I'm starting from here, north 70 degrees east means point north and then go 70 degrees east, which would be, say, about there. There we go. Get it? Because that angle there would be 70 degrees. So that line that I just made is north 70 degrees east. Let me use a different color for the next one. Suppose I wanted to do north 10 degrees east. I'll do this one in green. North 10 degrees east would be, there's north, and then 10 degrees east would be maybe just there. There we go. Where that's 10 degrees. There, that direction is north 10 degrees east. So let's make a triangle out of those two things. Okay, so her destination is 15 kilometers away on a bearing north 70 degrees east, but the first leg of her trip. So let's draw the first leg of her trip first. So she starts off from a spot, say here, and she goes this far. Oh, wait a minute. Hang on, that's a bad. That's straight north. Let's actually put some dot. Oh, jeez. Let's put some dotted lines so it's easy for me to tell my compass. I'm making a little compass rose right here. So north would be straight up that dotted line, but it goes 10 degrees east. So it's 10 degrees in there. And that's the first leg of her trip, and that's 14 kilometers long. And then she stops. Now, her destination is 15 kilometers away, but north 70 degrees east. So north and then 70 degrees east would make, I'm going to make a line with a different color here. So I'm going to make this a little longer so I can see better. So north 70 degrees east would maybe make this line here 70 degrees is like much further as an angle. Remember, 90 would be all the way from north to east. So 70 is maybe that far. And this line is 15 kilometers long. And then, of course, there's one more line. I'll make it green that joins those two. So we want to know how long this green path is. Any ideas? Well, I'm thinking I could figure out, let me make this diagram bigger so you can see better. I'm thinking I could figure out the angle between here and here. How would I figure it out? Any ideas? Very good. From here to here is 70 degrees. I guess I should have put that on the diagram, right? Oops, that's not the right color. This angle was 70 degrees. That's a degree symbol. So that angle is 70 degrees. And this little angle is 10. So the blue angle, let's call it angle A, shall we? The blue angle at A is the 70 degree angle minus the 10 degree angle. So angle A is 60 degrees. So this must be 60 degrees in here. Again, how did I know that? Because I know that from here to here, is 70, and here to here is 10. So what's 70 minus 10? 60. So let me simplify this triangle. Now I know that I have 14 here, 15 here, and 60 here, and I'm looking for that. Does that look familiar? What kind of a problem is this when you know angle between two sides? Sine law or cosine law? This is a cosine law problem. And again, I called this A, so I'll call that little side I'm looking for A, which means that these two sides must be B and C. So I'm ready for cosine law. Come come on, pen. A squared is equal to b squared plus c squared minus 2bc cosine of angle A. And I know all these numbers. B is 14, C is 15, 2 times 14 times 15 times the cosine of 60. I punch buttons. Punch buttons with me, see if that make sure I get the right answer. You're not the only one that can punch buttons wrong sometimes. Ooh, this worked out to a whole number. Oh, that makes sense, because the cosine of 60 is a half. So no decimal on that number. There'll be a decimal on the next number, though. Is 211 a perfect square? No. Somebody double check that. Anybody else get 211 when they punch buttons? I'll give you a sec. Yep, I'm getting a nod. So the square root of 211 is my final answer. And that's 14.53, and we're in kilometers this time. And there we go. So the second leg of her journey is 14.53 kilometers. And there we go. Well, does it? Oh, the one time I didn't go back and look. Good eye. You're right. That would have cost me half a mark. So it would just round to 5, right? Because the thing after the 5 is a 3. Good job. So there we go. Okay, I'll stop my little video now. And that's as tough as this stuff gets. If you can do problems like the ones on this little booklet, we can't stump you with sine law and cosine law, or SOHCAHTOA for that matter. Okay. Oops, that's not what I meant to hit.